I have just completed my PhD at the University of Michigan from the Department of Climate and Space Sciences and Engineering, and my specialization is planetary science and space physics. So yeah, I've been working with a NASA mission called Juno. So my doctoral thesis was based on exploring Jupiter's atmosphere and aurora through microwave remote sensing, and it ties to some of the big picture questions related to how these planets have formed, or what are the ongoing processes that we observe, and why are those things happening. So yeah, and other than that, I'm still exploring a bunch of interests, especially the application of science and how can that probably benefit my neighbors. If I can quote it from that way, Spider-Man has been a big influence for me growing up, so I want to be the friendly neighborhood scientist.
Hello and welcome to Indian Diaspora Podcast. This is your host Rahul. Today's episode is about planetary and climate sciences. It's going to be actually about Jupiter's atmosphere. And guess what? There are northern lights in Jupiter. We have with us Ananyo Bhattacharya, who just finished his PhD from University of Michigan, from the College of Climate and Space Sciences and Engineering. And we're going to talk about his journey from India to doing PhD in this space, his research areas, and also talk a lot about planetary sciences in general. Ananyo, welcome to the podcast.
Thank you so much, Rahul, first of all, inviting me to the podcast. And, really happy to share my experience and perspectives about planetary science and space applications.
Wonderful. Welcome. So you just finished your PhD from University of Michigan. Congratulations. That is a big accomplishment.
Yeah, thank you so much for that one. I can finally add that PhD tag somewhere on my post, and it's a special feeling, I would say. Finishing up that entire journey. Um,
Awesome. All right. Now tell us about yourself briefly. And I just painted a short intro, but tell us more about yourself, Ananya.
Sure. So I am originally from Bengal. So I was born in Kolkata. I have my extended family over there, and due to my dad's job, like we have been traveling all over the country. So I have lived in different places in India. I lived in Kolkata for some parts, in Chennai, in Chandigarh, and since the last 10-15 years, we've been staying in Vadodara, Gujarat. So you can pretty much say I'm all over the place, and I have experienced different cultures, different flavors, if I would like to put it in those words. And right now, I have just completed my PhD at the University of Michigan from the Department of Climate and Space Sciences and Engineering, and my specialization is planetary science and space physics. So I've been working with a NASA mission called Juno. So my doctoral thesis was based on exploring Jupiter's atmosphere and aurora through microwave remote sensing, and it ties to some of the big picture questions related to how these planets have formed, or what are the ongoing processes that we observe, and why are those things happening. So yeah, and other than that, I'm still exploring a bunch of interests, especially the application of science and how can that probably benefit my neighbors. If I can quote it from that way, Spider-Man has been a big influence for me growing up, so I want to be the friendly neighborhood scientist.
That is cool. That is cool. All right. Okay. The Juno mission. Tell us more about the Juno mission for those who do not know.
Sure. So Juno is basically a polar orbiting satellite around Jupiter. So it goes around the pole, at specific latitudes, and it is constantly spinning about its own axis. It's like a fan that spins around its own axis and goes
Okay.
around Jupiter. And there are various advantages to that. The main thing being that, if your spacecraft is constantly spinning, you're observing the entire sky, you're observing the entire environment of Jupiter, as well as looking at the planet.
Mhm.
So it's like a 360-degree review of Jupiter in many ways.
Wow.
Yeah, and I think the mission has completed almost 8 years.
Okay.
It reached Jupiter in 2016. It was launched in 2011, and it has several instruments to study various kinds of phenomena. For example, the clouds of Jupiter. We can study, some of the space environment, charged particles, radiation belts. Some of the most, like radiation hazardous, full of hazard places, like charged particles. Then the northern lights, the southern lights, how they are formed, and we can tap into how what Jupiter is made up of. We don't see its surface. Does it have a surface, or is there something else? How different it is from Earth, also how similar it is from Earth. So just like Earth, Jupiter also has clouds of water, which is very, very interesting, and
Hmm.
that drives some of the storms and some of the cool pictures that you get to see. Also, Juno had a camera, Juno Cam. It's still operational, I think. So it clicks images of Jupiter, and I think like those are the images you find all over. So not just science, but it has an impact beyond that. Beyond academia, if I would say. I just go to people and they pull up this phones and they have the beautiful Juno pictures, and I can come to them. I can say, I work with those guys, and it instills a different sense of pride in many ways. Um, yeah, so love to answer more specific questions about
Sure,
Juno.
sure. Yeah, I mean, for those who did not know, I did not know. The
Hmm.
Juno mission was launched 8 years back. There is water in the Jupiter's atmosphere.
Right.
There are northern lights and southern lights out there,
Hmm.
and interesting aspects that could be studied. The next question comes to my mind, Ananyo, is why study Jupiter, right? For us, in Earth,
Right.
my idea of standing understanding space was, hey, is there alien life out there, right? Or how big is the universe, right? Or what is a black hole? Or quantum theory applied to universe, right? But in all these possibilities, why study Jupiter?
That's a very, very interesting question, So Jupiter is the most massive planet, I would say, in our solar system, and probably the oldest one, from there are various theories of planet formation, which shows that Jupiter was the oldest planet. And wherever it was forming, whatever its composition was, understanding that gives us a knowledge about the raw materials of planetary formation in general, and how it was positioned, because massive bodies in space, they always affect the trajectory of other things around them. So it has definitely influenced in many ways the formation of other bodies in our solar system, and that's the primary reason why Jupiter is connected to the larger picture of how the solar system has shaped itself. you know and maybe where we are positioned today, it might not be explicitly connected, but that could be one of the possibilities.
Hmm.
And again, like Jupiter is full of storms. We have been observing it using a telescope, and we see storms on Earth. There are various similar features. We see cloudy patterns over there, and how does it affect the dynamical activities that's happening over there, versus on Earth? They seem to be much more extreme. There's the Great Red Spot that has been going on for centuries, and we don't have storms on Earth that are going on for centuries and wreaking havoc,
Yeah.
right?
So what's the
So
great red spot? You said the storm going on for centuries.
it
Like
is. It is a
how many centuries?
oof. I don't know. I think since the time people have started observing, maybe, and people are trying to understand why is it still going on, and also there are many various other cyclonic features. Great Red Spot
Wow.
is just one of them. How
Okay.
is it affecting it constantly? So
Yeah.
ultimately, it becomes the question of something is putting energy to this. That's why it's still ongoing.
Right,
It's
right, right.
self-sustaining to a
That's the
large extent.
scientific way of looking at it, But I just want to marvel at this thought. Imagine a hurricane or a tornado or a typhoon
Yeah.
that is going on forever. Okay. All right. Because,
Uh-huh.
what the universe teaches us is that, or at least perhaps the earth teaches us, that everything has an ebb and flow, right?
Mm,
Meaning, the four seasons, you know,
right.
or storms come and go. Everything that starts ends. I
Hmm.
can't think of anything that lasts a long time, except the sun rising and the sun setting and
Yeah.
celestial bodies rising and setting, which is basically rotation of the, revolution or rotation. That
Right.
said, in
Yeah.
that macro space, a phenomena like a storm or a red spot going on for a very long of time is fascinating from me, just as an observant. Over to you.
Right. And that's the reason why we need to go there. So I think in the 90s, there was a spacecraft sent called Galileo.
Okay.
Galileo had a probe that dropped into Jupiter's atmosphere. It burnt up, but it gave us measurements till, a certain depth.
Okay.
And that's probably the only in situ or, the measurement, the elemental composition of a gas giant atmosphere we know till date. And from that we can pick up certain patterns, and we can say, hey, nitrogen is more, sulfur is more, and why is this happening? Also, something very very interesting that led to Juno was that when Galileo probe went to Jupiter, uh, so I would quote one of the many scientists who were part of the team. So my own advisor was a part of the team, and it dropped into Jupiter, and it dropped in the Sahara Desert of Jupiter. So its objective was to measure water, but
Okay.
it dropped in a relatively cloudless spot.
Okay.
So it's an evolution of scientific methodology. Then they came up with let's try to observe it from the globe, maybe not go there, because we already have a lot of the important knowledge that cannot be observed through remote sensing. So this time they designed and added a microwave radiometer. Basically it measures the radiation or the brightness coming from different layers of the atmosphere, and by
Hmm.
scanning it at different angles, back to, as I said, Juno is constantly spinning about its axis. So it observes the atmosphere at different angles and takes a 3D scan in many ways.
Got it. Got it. So, okay. One more question on the red spot. How big is it?
Oof, I have no conception. It should be pretty big enough. I think so. Yeah. I don't know the exact statistic at this
Okay.
point of time.
Got it. All right. So, red spot is one of the interesting factors. We discussed northern lights and southern lights.
Yeah.
Um, what else is interesting about Jupiter?
Interesting about Jupiter, I would say, you know, I wake up every morning, I place, my feet on the surface. We don't know what the surface is for humans, for us to exist. We have to stand somewhere, sit somewhere. But the concept of having a planet which does not have a surface or something not observable, it's something which we don't come across every day, or, to think about in those terms.
Yeah.
And that's what Jupiter is about. It eventually built up itself, and now it's a massive massive planet. So there's something like a highly compressive environment going over there. It might not be solid, it might be mushy liquid, but that is what is holding Jupiter itself, and that is influencing the gravity. So what Juno and other spacecrafts have been doing, they take advantage of the gravitational acceleration, and then they try to understand what's the internal structure. And
Hmm.
we have a bunch of theoretical explanations, a lot of lab experiments going on. So it's a combination of different methodology combined with the observations from spacecrafts that we try to understand what's happening.
Got it.
And yeah, understanding this, I think, extends to a lot of worlds right now, because we also have exoplanets. I think there are almost about 5,000 exoplanet candidates. So we are
And what
not
is the exoplanet for those who do not know?
sure. So exoplanet is basically like a planet orbiting around other stars in other systems.
Okay.
And in today's date, we have the technology. We have had several missions to observe these planets, and some of them can be more massive than Jupiter. It can be hotter because it's closer to the star.
Yeah.
So there are many kinds of worlds that don't have, if I would say, like an analog in our solar system, and there can be many worlds which can be directly related to what we observe outside. So that is also a very interesting question, like what is our place in the solar system, sorry, our in the universe. Is our solar system unique, the tiny family, or like the magnificent family that we have, or is it very different? So I think it's more like we try to study people, and my community, or the people around me try to study planets
Yeah.
in that sort of way.
Yeah. Oh, fascinating. Like, space science is something you can spend your lifetime and still discover new things. So my question was, what is interesting about Jupiter? And the third point was atmosphere, or
Mhm.
rather lack of it in such a large body of object. Um, and so, okay, let me come back to the northern lights and southern lights. Like,
Right.
we have northern lights and southern lights here on Earth. You can see variations from
Mhm.
pink to magenta to uh, perhaps red to green and
Right.
slight tinges of yellow, right? Uh, how are lights or northern lights and aurora borealis? How are they different in Jupiter versus what we see on Earth?
That's a very interesting question. So I would say that the visible signatures, I think they're not the most dominant ones to be studied. We see signatures in infrared, we see signatures in ultraviolet. So it's more about we take different kinds of lenses to observe these planets. And the thing is that unlike our atmosphere, it is oxygen and nitrogen.
Hmm.
Jupiter is mainly made up of hydrogen and helium. So how aurora happens is basically there are electrons, protons, other kinds of charged particles going in and colliding with the atmosphere. This
Hmm.
excites the atmosphere or heats up. This is
Hmm.
the reason you see signatures in different wavelengths.
Got it.
And the strongest signatures have been observed in ultraviolet. So I think there was like a very old spacecraft that flew past Jupiter that detected some of this ultraviolet glow. Because it's like, think about it, like I take a camera. Okay, forget
Yeah.
about ultraviolet. I just take a camera, some novel camera, go to space, and some places appearing to be much more shiny than the entire body. That's itself is something unique to think about. And then eventually, people try to measure its space environment. We have theories of how the electromagnetic fields behave. So that's
Hmm.
how we know that what is causing this entire thing. And
Hmm.
probably by looking at the brightness, we try to measure what's the power of these things. Because when you pump in a lot of power, it's heating up the atmosphere, it's changing the chemistry. So, also something which people have investigated is that there are hydrocarbon hazes in Jupiter, Saturn, giant planets. And these are all getting, pumped up by these same mechanisms. So, yeah, it's like you get to see clear signatures when you go to the poles that, okay, this is appearing to be more hazy or more bright. And those are some of the proxies to study the southern and the northern lights. So it might not be that well in the traditional case, but we do have special cameras to look at these features.
Got it. All right. So the composition of the atmosphere, hydrogen and helium in this case, determines how the aurora borealis, quote unquote, looks or behaves versus the our atmosphere.
That's
Okay,
right.
interesting.
Yeah.
Are there any mysteries of Jupiter that we have still not figured out and we are puzzled by?
Oh, wow. Very interesting question. Yeah, like I would say a lot of things they evolve over time in planetary science. So, for example, think about this 100 years ago. We were here on Earth. We were observing many other planets, and I read very old papers. So sometimes when you read extremely old papers, 1960s, 50s, they tell you that this atmosphere has this composition. Now, me sitting in 2025, I know the actual data from spacecrafts, and they are contrastingly very different. And so I would say the understanding has evolved. Previously we used to observe storms. Then we sent one spacecraft, and we found out, oh, it's the most strongest magnetic field. It confirmed a bunch of ground-based observations. And then we found out that there are other features over there. There are in fact these cyclones at the poles of Jupiter, and they are constantly going. They are pretty much at the poles, if I would say. They go to various depths, and that was a pretty surprising feature. Like, what is causing these features to be active or alive for such time scales? The other thing was the interior. We did not know what's happening. We still don't know, probably. So previously, people thought there might be just like a core. There's like a very solid boundary. This is what the core is. This is what the atmosphere is. But from our current understanding of Juno, people talk about something like a diffusive core. The core is diffusing out, it is mixing with the atmosphere. And, like more data leads us to more mysteries. That's why we need more missions to happen.
Oh, wow. The more I know, the more I know that I do not know. Hmm.
Exactly.
Beautiful. Okay, I want to reflect two things you said, right? One are the cyclones on the poles.
Hmm.
Imagine cyclones in, the Arctic Circle. I think
Right.
we do get them in the Antarctic. I'm not sure. Certainly blizzards,
Hmm.
but I am not aware of. Do we get cyclones on the northern pole of Earth?
We do. I mean, we have like a bunch of wave features happening.
Okay.
But I mean, yeah, like constantly having like, proper cyclonic features, no.
Yeah. Right.
But for like planets like Saturn, Jupiter, I think a lot of
Right.
these things have been traced from instabilities on
Right.
Earth.
Yeah.
But people can, like explain this using some of the dynamics or the instabilities.
Got it.
The issue becomes that where is the energy coming from? So Jupiter has a lot of water cloud, a lot of other things. So
Okay.
there's a lot of convection happening that is probably giving up this energy. And
Right.
my colleague, my advisor, the entire group actually has been working on the problem. More from a measurement point of view, I would say they also work with people who make, these beautiful models of how airflow behaves
Right.
in cyclones.
Got it.
And it's about connecting the picture, I would say.
Okay.
But that being said, what Juno offers in terms of like a novel thing, we have the microwave radiometer instrument, we have an infrared instrument, and they scan the entire pole at different depths. So you
Okay.
can do a reconstruction and you can say this is where the features are active, this is where the features are not so active. And you can compare it with the background, like, okay, I
Got it.
see something significant here, you know.
Okay.
So we
Got
have to
it.
play detective sometimes
Yeah, yeah,
with
yeah,
the
yeah,
data.
yeah. That's the beauty of this field, Ananya. And next question comes to my mind. Speaking of poles, right? I see of poles as this, uh, you know, uh, entry and exit points from from where magnetic radiations emerge,
Mhm.
and it's Earth is like a giant magnet, right?
Right.
And so this brings me to the point of magnetic fields. Now, once you have I'm not sure if that is because of iron in our core, right? Perhaps yes. But if we come to
Hmm.
Jupiter,
Hmm.
have we studied the magnetic field around it? Does it look like what we have on Earth?
It does not look like what we have around Earth, but I mean, there are kind of similarities. Both of them have certain tilts. And also, like, what I would say is that, there are some localized features in magnetic field. Again, we are still connecting data. I think Juno is, so the best thing about Juno is it's a polar orbiting satellite. Again, back to what you mentioned, it's studying, it's surveying the entire magnetic
Yeah.
field in some sort of ways.
Okay.
And the more and more you go closer to the poles, we see certain patterns emerging in, the particles, their distributions. They're getting more energetic, and that itself is a very open question, as we speak. um yeah, but that being said, like, are you asking why they are getting generated itself?
No, my question was how different is the magnetic field in Jupiter
Oh, yeah.
versus
I
what we
mean,
have on Earth?
it's much stronger. I think it's the
Okay.
strongest in the
Okay.
entire solar system.
And what
In
would that
fact,
mean? What does a strong magnetic field mean? For example, on Earth, a
mhm,
lot of animals, pigeons, as they fly, they might use the magnetic field as the navigation, or these there are solar flares and they
yes,
mess with the magnetic fields, and our communication might be impacted. So these are two examples I can think of. Now I can't
yeah, yeah,
visualize.
yeah. I mean,
I do
you're
not
going
know.
towards
I do
space
not know when
weather.
we have a very, very strong magnetic field on
Mhm.
a planet. What does that mean?
Oh, wow, that's incredible. Back to the solar case, I would say. So
Yeah.
what happens is that the sun is constantly pushing particles.
Okay.
Sun is emitting photons as well. Sun is also emitting electrons. It's like a snowstorm. मैं ऐसे ही बोलूंगा. You go to snowstorm, you see particles coming towards you, right?
Got it. Okay.
So the Earth's magnetic field creates its own kind of plasma environment that
Okay.
has its own extent. And the sun's and the Earth's influence clashes each other much like a fluid, you know.
Interesting. Interesting.
And that's what creates what we call Earth's magnetosphere. Similarly, Jupiter has a magnetosphere. It's much, much larger than anything. And I think some books quote that if you could image Jupiter's magnetosphere, it could be observable probably in the night sky. You know,
All right.
it has a certain pattern to it. There's a elongated tail, and in terms of the mechanisms, I think yeah, it's very different in Earth and in case of Jupiter, but that's into the more technical details. There are different mechanisms governing energy transfer over
All right.
there,
Got it.
because the sun also has particles, its own emanating magnetic field. I don't know if it's the right way to phrase it,
Yeah.
but different systems interact, and that is giving rise to all sorts of phenomena.
Got
So
it.
in the last probably like 5-6 decades, such theories have really been well formulated, and what this mission has to offer, or any new mission has to offer, is that how does it probably change with time. If we have more monitors in space, I can look at the sun, I can look at this planet, and I can say, a very interesting example came last year, maybe last year. It was a paper published in Nature Astronomy that said that we did a Uranus flyby. It was Voyager 2. That's the only Uranus data we have. Okay.
Mhm.
Over there, when it reached Uranus, there was apparently some kind of an extreme solar phenomena. And
Okay.
that is probably leading to an anomalous distribution of particles around Jupiter's space environment.
Okay.
So it might not exist 95% of the time. We're looking at a very special case.
Wow. Okay. Got
So
it.
that brings us to the question that what are the other possibilities,
Yeah.
because these planets have moons, and some of the moons also have liquids. They are always ejecting something out, and by tracing those particles, you can kind of determine if the moons, what is the source of these kind of particles. Is there liquid water oceans over there?
Yeah.
Is there some sort of active processes shaping the surface? So like all these questions in many ways become very much coupled to one another. You can understand the planet, you can understand some of its satellites. So
Yeah.
back to the Jupiter system. Jupiter has this moon called Io, or some people call it Eo as well. um,
How do you
it,
spell it?
it's I and O. It's like input
Okay.
output IO.
Got it. Okay.
And it's basically the most volcanic world in the solar system, and it
Most
ejects
volcanic world in the solar system, like of all the moons of Saturn's, Neptune.
everywhere.
Wow. Okay. Carry on. Carry on.
Yeah, like I think it was the Galileo spacecraft that imaged a lot of the features over there. So there are puddles, or like people call features of lava lakes, and people what they try to do.
Even more volcanic than Venus, which is much closer to Sun.
So for Venus, we have very few, like coming to Venus, we have volcanic site evidences,
Okay.
but on Io, we have, I would say, like, okay, Venus science is advancing. Coming to that question, there are recent papers which are showing a lot of volcanic evidences, like resurfacing. That theory is going on. But
Okay.
we have seen more active features over here. Like, there are images clicked, and people could see, you could see some ejections coming out of certain points.
Okay.
So if you just Google, like any
Yeah.
kind
Yeah.
of
Yeah.
Galileo Juno image, you will get these bursts sort of coming out. And the
Got it.
second thing is, unlike Venus, this does not have a thick atmosphere. It might have a thin surface bound exosphere, whatever we call it.
Yeah.
And it's giving rise to some sort of maybe SO2, sulfur species, oxygen. And eventually they get energized, because since it does not have an atmosphere, nothing is protecting it.
Hmm.
Some of it gets stripped out, it gets into the Jupiter's environment, that is getting deposited on the poles. So these moons itself, they also give rise to some of the features in the aurora, in fact.
Really? Okay. Wow. That's fascinating. Okay, because of course, those particles then interact. The gravity of Jupiter pulls them closer, and they interact with the atmosphere, or in
Yeah,
the atmosphere with the sun's rays.
yeah, it's
That's
it's
my
it's like
hypothesis.
as you said, I would say the magnetic field,
Yeah.
actually. And
Got it.
the other moons as well. So what happens is that, imagine every particle is coming out, some of it
Okay.
gets over there.
Okay.
And what people have done, Hubble Space Telescope is a good example. They have taken ultraviolet images.
Okay.
They see that the main aurora has a certain shape to it, I would say, statistically. And then there are these circles which are constantly dragging and moving. And the reason is that it is coming from the moon. So as soon as the moons are rotating, it is also rotating with the moon.
Got it. All right.
So these are mobile features of the aurora in
Yeah.
many
Yeah. Yeah.
ways.
Fascinating. There's so much to study. All right. Cool. Next interesting aspect perhaps is gravity. You know,
Hmm.
gravity of Jupiter. So the first time men went to moon, right? They obviously, they saw that they could jump higher, right?
Right.
That is the first example, if I'm not wrong, of human experiencing gravity on a different celestial body.
Hmm.
Hypothetically, if a person was to land on moon, sorry, on Jupiter, um, how would gravity
It's
affect them?
probably three times that of Earth. I think the gravitational acceleration, yeah, around 24.
All
Uh,
right.
so
Would they be
it's
able to
much.
walk?
I don't think so. You would feel probably more heavy over there, probably three times more heavy, and it would of course cause much more difficulties. It's the most massive planet, so the strongest gravitational acceleration in
So
many
what does
ways.
three-time gravity mean for those who do not know?
Yeah, sure. So basically, imagine I take a hypothetical surface, any planet, and I just drop an object. Due to the gravitational force, it is getting pushed or attracted towards this
Yeah.
body.
Yeah.
And the level of acceleration, that's what is known as the acceleration of gravity, and that is what we generally measure.
Yeah.
In fact, it pushes the mass of fluids as we see on Earth. So gravity plays a big role in how the atmospheres are shaped in many, many ways.
Hmm.
And speaking about Jupiter, it's larger than the Earth, more massive. So if even if I talk about the surface of Jupiter, like equivalent to the surface pressure on Earth, the gravity is three times higher over there. And that is actually, like I think it was probably from human conception or something. We
Hmm.
use the 1 bar or like surface like measurements as more like a datum. Okay, this is the reference. With respect to this reference, there is something above, there's something deep down over there.
Hmm.
Yeah, and the gravity itself is a fascinating phenomena. So as I was saying, like the spacecraft itself goes around Jupiter. You can measure the acceleration of Jupiter because it's transmitting some of the data to ground station back to back from time.
Okay.
And from that, you have to do some sort of Doppler corrections, and basically you can get what is the actual acceleration due to the gravity.
Okay.
And yeah, it's pretty fascinating because then people develop all these beautiful theoretical models,
Yeah.
and they can basically interpret like what regions are sensitive to the measurements. So
Okay.
then I can kind of come up with my own conception of how dense the matter is,
Yeah.
or how is it behaving like. And we are still pretty much in the process of these things, because I'm
Yeah.
talking about, I don't know, like it's a million or a billion times the pressure that no, maybe like a million times the pressure we might feel. So
All
it's
right.
not
So
easy
I
to.
want to contextualize this. So sorry for interrupting. So imagine if a person is 80 kgs or 200 and 200 pounds. Okay.
Okay.
Uh, let's say 80 kgs. Okay, on Earth. All
Mhm.
right. Um, Now if that person goes to Jupiter,
Mhm.
right? Of course they will be heavier, right? But will they be like three times heavier? I'm sure somebody's going to correct me here, but will they
Yeah,
be
yeah,
three
yeah.
times
It
heavier
would be
now?
three times heavier, but the mass itself stays constant. So when we talk
Right.
about, if I would say kg jab hum bolte hain,
Right.
it's kg weight when we say weight, and the weight comes from the fact that we are on Earth.
Okay.
Earth की gravity is more or less same everywhere, so it's
Right.
the g that we know, and
Okay.
वो जो g है that goes thrice on Jupiter, so it might become three times the kg weight,
Okay.
but my
Three
mass
times.
is constant. It's just
Okay.
how I'm
So
getting
now
it.
now think 80 cross 3, are you able to carry that weight and walk?
Oof,
Right?
it's yeah, it's a lot
That's
of
what it is.
column
Okay.
pressure.
Oh, okay. Now I can contextualize. Okay.
It's
All
deeper
right.
than probably the some of the submarines we have been
Okay.
to. And
Wow. Okay. All right.
and again, back to the point, if we are sending a spacecraft, it has to withstand those pressures.
Right. Right. But withstand those pressures even though it's on the orbit,
Oh no, if I'm dropping a probe,
dropping a okay.
yeah.
Okay. Got
Like if
it.
somebody is too
Yeah. Yeah.
adventurous,
Yeah.
wants to have like I see those. Is it maybe like maybe Red Bull does a lot of things, jumping from
Yeah.
different
Yeah.
heights, doing sort of adventure sports.
Right.
So if people want to do that, then these are some of the important
Yeah.
design
Yeah.
considerations.
One day I'd like to see somebody juggle some balls in Jupiter.
Absolutely.
All right, cool, cool. All right, nobody has given so much love to Jupiter as in this podcast, Ananyo.
Oh yeah, it's my thesis. I can go on.
You can go on, Ananyo. Is that what you discuss on dates, Ananyo? Jupiter.
No, not at all. I mean, it's just a part of my profession, and
Right.
you know, I think I'm more like, if you ask me something, I'll be able to answer that, and like Jupiter is one definitely big planet, I would say, and but growing up and in my undergrad, one of the biggest things that I was looking after was like Venus, the
Yeah.
exploration of Venus itself.
Yeah.
And right now, I think India has approved a Venus mission.
Okay.
So it's gonna go sometime in the, I don't know, maybe in 5 6 years, 3 5 years.
Yeah.
And like when I was a student, there was a call for instruments, and people were designing, making. So things are in process. Things are
Yeah.
really growing up in India, and you know, last to last year only Chandrayaan 3. So
Yeah.
uh, we had a landing party actually here in Michigan. So
Yeah.
me and there are a few friends who actually are from India,
Okay.
and like I have heard the term growing up generally, like there's a launch party, rocket is launching,
Yeah. Yeah. Yeah.
and here we have a landing party, which is pretty amazing. And we watched the scientists and engineers,
Yeah.
they were really celebrating. And it echoes me with a lot. I would say this one I was more alone in my own space because I'm in US.
Yeah.
Chandrayaan 2 something, like I was probably in my second or third year of undergrad.
Okay.
So I was in NIT Surat. I was sitting in my hostel.
Yeah.
I think we were watching landing, and I could hear so many voices, cheers. It felt like a cricket World Cup, nothing
Yeah.
short of it.
Yeah.
And
It was spectacular that time, that day.
it
Yeah.
was, and like if I could give you a very recent example, so I traveled to India like few months ago.
Okay.
Fortunately, I could see a PSLV launch this time.
Okay.
And like it had a bunch of payloads from different universities, startups, and all of them all were in the same gallery. And
Right.
I just as soon as it launched, it was put like it was placed over there in the orbit, and people were so happy because it's maybe years of hard work that they
Yeah.
see, and
Yeah.
um, that is taking them to a point, kya bolte hai, like chanda mama, and like like bade hote hue, we have heard those kind of stories, and now you're placing objects over there,
Yeah.
your own work.
Absolutely. So let's give direction to this talk, right? So far we discussed about Jupiter,
Mhm.
right? We asked a lot of interesting questions, and we sort of transitioned into different missions. You mentioned about Venus,
Mhm.
Chandrayaan, etc. Let's sort of go to your after your engineering. You did your engineering in mechanical engineering from NIT Surat.
Yes,
So, like many, you know, young souls out there who could take different paths, you had a very interesting progression into the space of planetary science. Let's understand that for the benefit of others, right? So, take yourself back to your days at NIT Surat,
Mhm.
and then talk to us about how did PhD in this space come in your mind, and how did you, what are the interesting things happen, like
Yeah.
naming a star, for example? Let's visit that and walk us through the steps and towards your selection at University of Michigan.
That's true. So I would like to answer your first question.
Yeah.
Going back to the undergrad, maybe I will go back to like my school times, because that's where it all started. So I was interested in space as any kid would be, and like when I zid kiya, and my father got a telescope. So I think it was eighth standard, and every night I used to watch, go, and they used to have a software with that. So I used to target stars or planet, from that software, and used to watch. But what like kind of maybe got into my mind that we have reached there in the 70s, 80s, and we are still trying to go there, and these are worlds we could go to. So that was one of the things in my mind, that I probably want to study them by sending spacecrafts, you know, as close as I think see, like see things on Earth. And something which inspired me throughout the years, like school se lekar ke undergrad, I try to watch films from time to time, and there are films kya hoती hai, stories hoti hai around us. So, like we know people, we know how they look like, their gully, mohalle, everything. But then there are these strange planets, storms happening, cloudy. We don't know what's there. So it was about exploring those kinds of stories, and they are as massive, sometimes smaller or larger than our own Earth. So there might be more stories over there that we have not unraveled. And it was about bringing the planet that closer to the people, that, hey, this is what this world looks like. So giving it a feeling of, if you stand on Mars, how would you feel like? Is it similar to the deserts on Earth? Is it very, very different? What is it like? And engineering, I would say, like, probably India mein, like, like we had more of this thing ki, like it was seen as a stable career option, or, many, many things, probably a societal push. But I tried to optimize on top of that. So that's why I took mechanical engineering. It was a very conscious decision because I could study the physics. I could study, like some of the thermal fluid dynamics things. And those things are also applied to other planets. So it was a very direct relation. Now coming to the undergraduate part, so yeah, I mean, traditionally these things are not taught in undergraduate. Mechanical engineering is something very different, and I really had a great time in that. I got to know so much about what other people do, all the fantastic designs. But like I was at that time like more interested in like what is this planet in itself. So I came across maybe like a call or opportunity. Somebody else was doing like a simulation of Venus fluids. And I was like, okay, I am interested. I want to get into this. And at that point of time, it was like, okay, Venus is not interesting because in media and everywhere you see Mars, Mars rovers, everything is happening over there. Like Venus, okay, I don't know. I want to learn more. So that person sent me 3, 4 papers. And honestly, like, I think that was one of the first moments I think which consciously I feel मैंने इतना invest किया in reading something.
Hmm.
I read about the entire planet for 3, 4 days. कुछ time बाद it was like, so there's a phenomena called super rotation. It's like Venus का जो cloud होता है, which is like about 60 kilometers from the surface,
Yeah.
40 to 70. That
Yeah.
rotates 60 times faster than the solid body of Venus itself.
Hmm.
And it's because there is some kind of energy transfer processes happening over there, but we wanted to do it in some kind of a solver or something like that. That was the basic simple study. But what happened was when I saw that, I thought of it maybe like one of the scenes from Mission Impossible. Like things are just moving around me. I am in this sort of extreme environment because the surface pressures on Venus, that's like 90 times the surface pressure on Earth. You know, it's a totally extreme different environment. And I'm like, that's a nice challenge. That's something, like I want to go for it. And for some reason, it was purely out of passion. It was like I like this story or I like this challenge and I want to go for it. It might be arrogant for me to say, but at that time I was like, okay, I don't care दुनिया क्या कर रही है, Mars देख रहे हैं, ये देख रही है, I want to go for this one. um so we did some presentations in international conferences, and after that I was like, ये सब कर लिया, but I need to get more scientific training, you know and I reached out to researchers, lots of cold emailing. Fortunately, some people from physical research laboratory in Ahmedabad, they responded, and I could learn from them, for the rest of my undergraduate years, as well as present some conferences, collaborating with them. And I think that has been one of the most fruitful experiences. I mean, this is something which I think everybody does, is ki immerse yourself in that community of people, where you want to go, because there's already a lot of problems that they have solved that you're encountering, and have mentors in that way who will probably tell you, okay, these are ABC career options from here, or there's this is something new you could explore. And Planetary science is a relatively small community. So when you get inside there, you kind of know people, like something funny which happened was, so I mailed this professor at Georgia Tech during my undergrad. Out of the maybe grad admissions ke liye, maybe something like that. And 2 years down the line, I meet him at a conference. And my advisor was about to introduce me to him. But he comes forward and he somehow remembers my name. Now that's like an amazing quality of him. But that's what I'm saying. Like, I know this person since my undergrad because मैंने papers पढ़े हैं, मैंने उनको present करते हुए देखा है. And I think that's something, which I still try to digest, because 5 years ago अगर मुझे आप बोलते कि मैं ये सब कर रहा हूँ, ऐसे ऐसे लोगों से मिल रहा हूँ, make instruments, do these things. And even if, I'm getting email ka title है Venus, Jupiter, that's not something which I was used to. Um, yeah, so that was really, really fruitful. And from there, I would say, like, it was a great experience. I presented at the Indian Planetary Science Conference. I saw, I think, a lot of scientists who were part of the Chandrayaan and Mangalyaan teams. And that
Mm.
point of time, future Chandrayaan 2 and Chandrayaan 3. Um, yeah, so it was quite inspiring for me. And when you see such role models, people, you internally like normalize it, ki, हाँ, ये हो सकता है मेरे life में. This is not something, which is impossible. And I
Mm.
think PRL or, other institutions like that, ISRO has done that for me in many, many ways. But you were also asking about the PhD. So how did I come to the PhD program?
Before we go there, how did naming the star happen?
Oh, yeah. Chronologically, it's in the correct manner. Sorry. Yeah, I will say about the start. So what happened was ki, basically summer vacation chal raha tha. I was scrolling Facebook posts and I came across this name, the ExoWorlds competition from International Astronomical Union. They were like कि there are many countries and उन countries से ये star दिखता है, and each of these star have a planet around them, basically exoplanets. So the goal was to name those stars and the exoplanets in the native language of those countries. So that was something very, very interesting. So at the same time मुझे ये because I try to follow some kind of science pages, researchers con है, and it's very interesting. I somehow end up as I said, probably for me the motivation is also about stories. So it's not just the science, but who is also doing the science, because they are a representative of those kind of communities, those kind of backgrounds, wo jaise aise environments aaye hai, their hard work. So it's very important to give value to them. And I think that kind of drove me to read about this person called Bibha Chowdhury.
Hmm.
So she was the first, I think, Indian woman to get a PhD in physics. She got it from UK, and yeah, like then what I read, like that surprised me. She worked with Vikram Sarabhai. She worked with Homi Bhabha, and in fact, they brought her to India to work at TIFR PRL.
Hmm.
And like and after that, and this was written by some science journalists at that point of time, like a short book of hers. And then in a way, like like unke bare mein utna information nahi milta hai for some reason, which
Hmm.
was, I
Right.
don't know why.
Her name is.
um,
Let's give her the limelight. Her name is Bibha Chowdhury, right?
Bibha
And
Chowdhury.
can you
uh,
talk more about her? Where did she come from? India. A brief
sure,
story
she
on her.
she is from Kolkata. I
Okay.
Her field of research is particle physics.
Okay.
And it's like she worked with other many renowned particle physicists at her point of time.
Okay.
Yeah, then she went to UK. I'm forgetting where she did her PhD from, but she went to UK. She was one of the handful of women who are doing like PhD in physics in UK, मतलब foreign international students, जो आज के डेट पे मैं भी हूँ एक. uh, you know and she did a lot of visiting fellowships, and invited by Homi Bhabha to join TIFR and then subsequently PRL,
TIFR is Tata Institute of Fundamental
Fundamental
Research.
Research,
PRL is Physical Research
Physical Research
Laboratory for
Laboratory.
others. Okay.
Yes.
Carry on.
And after that, I think she went back to Kolkata, but she was not very, I don't know, like maybe not so vocal about her, like perspectives or research.
Yeah.
And It's interesting because every time you hear about somebody who is associated remotely even with Vikram Sarabhai or Homi Bhabha, they are founders of the space program, like the nuclear program, so many different applications. And I'm a beneficiary of that ecosystem. So
Yeah.
it's like, knowing these people, it's very important. So
Yeah.
pata nahi, that was like a child play, if I would say, but I was like, okay, मैं इनका नाम डाल देता हूँ,
Okay.
in that, and I did that. फिर दिसंबर में मेरे को, I think I get a call कि these are the selected ones. There was a voting round,
Okay.
and I think this was just before the pandemic started.
Okay.
So I got a thing कि this is the result. मुझे एक email आया. Right now it's under embargo, but your name is the winner from India.
Whoa.
So I
And like,
named the
were
star.
you the only one from India, or
So
there were
I
more?
named the star. There was another person who named the planet.
So
Planet
two
का नाम,
people from India.
two
Oh,
people from India. So there was
wow.
another
Okay.
person. I think his name is Vidyasagar, and he
Okay.
named the planet as Santamas. And it's interesting, like so. Yeah, Bibha means a ray of light, basically.
Okay. That's
Very
so
apt
apt.
name for a star.
Yeah. 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 And so where is, I don't know what does this question also mean, or how do you answer this? Where is the star Bibha Chaudhuri in the universe? How do we understand that?
I think it's something somewhere in the Sextans constellation. That's what I remember, and
Okay.
it's
Okay.
there's an entire like a code for that. I'll probably share the description with you.
Sure.
Uh, there's like a catalog code for that,
Hmm.
and it's the common name for that star. Like common name for any other scientific discovery, if in many ways.
So
So
if I
आप
if
बुला
I
सकते हो.
Google Bibha Chaudhuri star, will I get something? Will I get
Absolutely,
the
you
name
will
of
get
the star?
everything.
Okay. All right. Okay.
So
This gives new meaning to this. Often we heard in films ki after we die, we become one of those stars.
yeah,
Interesting.
like so uske just baad, like I was invited to be at there was like the largest gathering, astronomy का सबसे बड़ा conference होता है, and then I was
Hmm.
awarded the prize. Oh my
Okay.
God, I met all the institution directors over there. That was
Yeah.
something else. मैं
Yeah.
undergraduate में हूँ, मैं
Yeah.
engineering कर रहा हूँ, and I meet these giants, and some of them are
Yeah.
like various project directors, institute directors.
Yeah.
And वो हुआ उसके एक दो वीक बाद I go to physical research laboratory for a planetary
Yeah.
science conference.
Right. Right.
So
Right.
that those few weeks for me now was something else. I was like dreaming,
Yeah.
and
I mean, I can't imagine. First of all, I'm going to go to that space you were in your undergrad, and you named a star two out of your country, India, and then you meet all of this top of the top in their fields.
right.
Wow, that's so cool. Would you say that's when the direction of your life started going towards the PhD that we're going to talk about, right? Is that, or it was before that?
It was a few months after that,
Few
precisely.
months after that. All right. One thing's led to
So
another.
हुआ
Okay.
क्या कि that was the COVID pandemic time.
Yeah.
Things got closed. I
Yeah.
went to my home. I think it was Holy Break or something. I did not
Right.
return.
Hmm.
हम लोग को वहीं पे we got instructions because lockdown होगा, and we had to
Yeah.
adapt.
Yeah.
And I think the biggest thing was me being with my family and the way they
Yeah.
have supported me. Without
Right.
them, nothing would have been possible. Right now, when I come here or when I look at other senior people, like there were many people who were not with families, and
Okay.
the struggles that they have gone through during those times, irrespective of what any organization, any municipality, or anything that does, that feeling of being lonely and also like, feeling of being with family, those are two
Yeah.
different things at all.
Absolutely.
And I'm really grateful that at least I was present with my family. I also got infected. That's a different story, but like my family took care of me,
Yeah.
and that's how like I pretty much got out of that entire phase.
Yeah.
So what happened was when I was taking the train back to Vadodara. So I'm in Surat, and Vadodara, it's like a few hours train journey. And over there, I see this ki NASA has put out 4 mission proposals that are going to go. Two of them are Venus missions. Now, at
Okay.
that time, I was like, okay, this is my focus. But I'm like, okay, ठीक है, मेरे लिए news है, मैं क्या करेगा? You know, I go there. Pandemic starts, like different things happen. Now I cannot go to any other facilities. So I start cold emailing people. And for some reason, Venus, like the depths that I told you about, it's highly pressurized environment. People are still doing work on that. So that's a very interesting environment to look after, how maybe things are going over there, temperature, pressure. And I start in a way bothering or communicating with a scientist, in here in US. And we have a mail exchange for about 3-4 months. He
What was
gives
your opening email so that you got a response?
It was a very wild thing. I have to be honest with you, Rahul. Like it was like he had a pressure chamber which could simulate Venus. I'm like, okay, I want to do some experiment. I did not think मैं इंडिया से हूँ, कहाँ से हूँ, क्या हूँ. I was like, आपके पास चेम्बर है, मेरे पास आइडिया है. I want to talk. So that happened. This went on, and it was like, okay, I could not do the experiments, but the corpus of knowledge, different fields or things like that.
Yeah.
I focused on this one singular topic, and I probably wrote like a 20-page report on that, and I gave it to him, and he's like, "Arey, you have so much of information. Make it into a presentation and present it at a conference."
Yeah.
And he said that do it for this mission concept called Da Vinci Plus. So
Okay.
back to the time when I was catching the train, Da Vinci Plus was one of the 4 missions that NASA had selected for
Okay.
the other round, and that was something really, really interesting. So the dots really connected back in many, many ways. And yeah, so after that, I gave presentations. I also was like, okay, but can you get a consent from your mission PI, because I'm an international student, I am doing this. It did not make sense to me, but fortunately one more thing happened. It was virtual conferences that time, so I could present by sitting in India.
Okay.
I was doing all the work just by sitting at my house, and I presented at 2 conferences, the American Geophysical Union, and there's like a Venus specific conference.
Hmm.
And the next summer it gets selected as a mission.
Okay.
It actually does. And
Hmm.
what happened was, by that time I was like, okay, I want to do this, I'm passionate about this. The next step is probably like, like a master's or PhD. And I saw where, I could do like both or whatever. In US universities, you did not have a requirement that you need to have a master's to get a PhD.
Yeah.
And I was like, okay, I am very much niche into this. Like, I know the people in India who work on this in other places. And, like, I should definitely try my best. Papa ne काफी encourage किया. He has hyped me a lot. And it's like, I applied, but I applied a few places, and one of them was University of Michigan.
Okay.
And Michigan mein, there is a specific professor, Professor Sushil Atreya. So he ended up becoming my advisor.
Okay.
And he is one of the, I would say, like one of the oldest Indian origin planetary scientists in the field. He has been
Dr.
on
Sushil Atreya.
Sushil Atreya.
Got it. Okay.
And yeah, he has been on a bunch of missions. He has been to, I think, almost every outer planet mission. He started career in Voyager. He was on Cassini. He was on the Galileo. In fact, जो Jupiter के composition के papers मैंने आपको बोले हैं,
Yeah.
it was from our lab.
Wow.
So in fact, then this I got to know much later. He is a scientist on Da Vinci. So that's
Okay.
how I was, like in the picture, and I got hired as a PhD student, and got inducted. Hired might not be the right word. Uh, and yeah, that gave me a new sort of platform, because like I was in engineering. I did not have any formal training in this field,
Yeah.
but I've been always searching for somebody who could probably give me that direction, correct me where I'm going wrong. And it's necessary, like now I feel that my undergraduate self was very much enthusiastic, maybe not that much aware about things around.
Mhm.
I'm still enthusiastic, but like right now I think I have a little bit more experience of how things go, or what rigor should be, or how things need to be done in
Okay.
research.
Wonderful. Couple of things to learn from your journey. One is surround yourself with a community that you're very passionate about, right? Second
Right.
is you really went so deep, for example, with Venus.
Mhm.
that you really knew a lot, but you also loved what you knew, and that love actually opens up more doors. The star naming of the star project that you got involved with, and
Right.
then of course cold mailing others, right? Like what are others doing, what you could offer, irrespective of where you are, uh, and bringing all your knowledge and skills to that equation.
Mhm.
In a way, Venus got you Jupiter.
Yeah, that's another interesting thing. So they were already funded for Juno. So when
All
I
right.
came here, like in India, like people are not much focused on outer planets research. It is expanding, I would say.
Okay.
And here I come, and the first thing they offer me is "Tum Jupiter ka kaam karo," and I
Okay.
was sort of given a red pill and a blue pill question. Either you
Correct.
study the great red spot of Jupiter, which was supposed to be one of my topics,
Yeah.
or you study alkali metals in Jupiter. That's
Okay.
what I was given, and I took the Matrix, the one that I did not hear about, and that has kind of changed my entire
Got it.
doctoral life or the
Yeah.
way
Yeah.
things
Yeah.
are perceived. Um,
Fascinating. Fascinating. We are almost at the top of the hour now, and this was
right.
a great reflection starting from Jupiter to, your journey from a student life in India
Mhm.
to the beautiful world of planetary sciences and climatic sciences. Where do you want to go next, Ananya?
That's very, very interesting question. So I think my research has been mostly focused on planetary science, something which I want to do, and connecting back to stories and everything. Um, Probably, like one thing that fascinates me is applications of science. Like, I'm doing something for my natural curiosity, but is it helping my neighbor? If both the things are same, I'm kind of maximizing. I don't know. Like, I think this concept is used a lot, ikigai. uh, and that's what I also learned from a lot of people. So Michigan has taught me something. I think is like goal setting is very, very important, and secondly, having good mentors.
Hmm.
um, because these relationships ultimately they tell you that what they have gone through, and they also see a version of themselves in you. Like they also wished ki agar if they were young, they also had people who could like guide or things like that.
Hmm.
And I think that has kind of shaped, and like it gives me a strength to think about many things.
Hmm.
Especially like earth observation is a very big thing. That's why I mean that's how the entire Indian space program was shaped. It was
Hmm.
first for India for various civil applications,
Hmm.
and then we explore space once this is more sustainable. And similarly, like we have a bunch of spikes coming up in terms of missions, but if we want to really expand, then like making this planet, I guess, making those chains more concrete, that and then eventually looking outside. And also, like as I have maybe highlighted, Kate, there are various places in the solar system similar or different to Earth's. So bringing those two pictures to people, I think that's what I would be interested in.
Sure. All the best on that journey, Ananya. Okay, this brings us to the last fun rapid fire segment.
Oh
Okay.
wow.
Yeah. Have fun. We're going to ask some interesting questions and get some interesting answers from you.
Mhm.
All right. Okay. So, hey, are you ready?
I am ready.
All right.
Yes.
Cool. Okay. So, your first one is, if Jupiter was a person, who would
Mhm.
that person be?
Ooh, Jupiter was a person. I mean, interesting. I think I would have to go to Greek mythology. There's no answer to it, but Jupiter is probably like the king of all planets. Um, so it's like a personification of king. If you say it's Mars, if you say it's satellites, it's like the entire praja of this king, and this person has so many assets, that is empowering this entire system.
Yeah.
I would say a good king for good reasons.
All right. A king. Okay. Cool. Whichever king comes to your mind. All right. Cool. Next one. If Elon Musk developed a rocket for you and, you could survive, think oxygen, water,
Mhm.
which planet would you choose to live?
Wow, interesting question. I would say Venus. I think, like since my undergrad, like probably universe has been hinting me that I need to really start investing my time and exploring some of the things. And if I get an opportunity, that's the planet I will go to. Also because we talk about Venus is hot today because of greenhouse gas effect that went into its extremes. We see some of that on Earth. And understanding Venus, it tells you a lot about how planets are evolving. Even if we get a tiny switch from one place to another. So I think that would be one place to go for me.
Venus, somebody loves you here.
Venus, somebody loves me, I mean.
No,
Yeah.
no, Venus, somebody loves you. Like it's you actually. What I'm referring to, men are from Mars, women are from Venus.
Right.
Men are typically associated with Mars in popular literature, and of course, Venus is hot, so
Yeah.
yeah, I love your passion for Venus. It's gotten you ahead.
I think there's a bit of Mars and Venus in everybody, I would say.
Yes, nice
And
answer.
there are aspects that people pick out of.
Sure,
So, like I think that's what is the most fun part about studying planets.
absolutely. All right, next one. What is more important to study, planetary science or climate science?
In the immediate term, and always climate science, I would say so, because, we are here on Earth, and that's how this entire thing started. See, planetary science can be done. It can be done in many, many ways. And I would say it has these two fields have different goals. One thing is understanding how like naturally Earth is evolving,
Yeah,
like, and many other things. And coming back to the bigger picture, Earth is also a planet, so it is a part of planetary science. Probably, like if I want to study other planets, its differentiation, I would say, like our techniques have to be strong enough, and if it's like, if we destroy our headquarters, why how will we expand? We need a
exactly.
headquarters from
Yeah.
which we can send missions.
Love that. This question was like, what's more important? Is health more important or nutrition? Both are, but I don't know. Maybe immediately, climate science because that's going to kill you if you don't study it.
Right.
So I don't know. Studying heart disease is more important than for immediate than let's say nutrition. Which is long term.
Yeah, I would say still, like understanding stars, planets, their positioning,
Yeah.
that has kind of culturally evolved us, and right now, it's taking us to new levels in terms of thinking.
Right.
Something which so there was Dr. Thomas Zurbuchen. He came here some
Right.
time back, and I get these questions like why space research is important, and he basically pointed it out. You take any speech in the world, if you
Right.
say any human accomplishment, like there are a few guests in Michigan, they were also talking about biggest accomplishments of, let's say, India in terms of technology. You
Yeah.
always have space in there. It's somewhere in the advanced technology category. It's also because it's a very different world. We are
Right.
something that is not very usual to us, that catches our attention.
Right.
And I think it is a very different way of looking at it, but expanding planetary exploration, that will intellectually benefit us in the longer run, I would say.
Absolutely. All right. Your next one. Pluto is a planet or not?
I will leave that question to Neil deGrasse Tyson, I guess. Like I met somebody maybe at Caltech. He places a sign outside his office or somewhere. Some people told me that he's the Pluto killer. So he was the reason Pluto is not a planet, and things like that. But that being said, I know a few people that study Pluto, the thin
Okay.
atmosphere of Pluto, and it's a totally different world. And like people are still trying to get more data. New Horizons spacecraft went there maybe in 2015, and we got a picture of Pluto which has like a valley shape of a heart or pretty much similar.
Hmm.
So Pluto sends its love from space. Planet or not planet, doesn't matter probably.
Send it to Neil deGrasse. Neil deGrasse. All right, your next one. If you were not studying planetary science, what would you be doing rather?
Oh wow, that's interesting question. I mean, if you ask the probably the curious child in me, if you're directing that question to that person, I would say detective. So right now I'm a planetary detective. So it kind of satisfies, a criteria in a certain
Cool.
manner.
Yeah.
Uh, yeah, I mean, I have been fascinated with comics and like storytelling, and I think that would be one thing because you're constantly thinking about possibilities, connecting dots.
Yeah.
Uh, that really like motivates me probably.
Wonderful. And finally, one person in the field of planetary sciences that the world should know about.
Oh wow, that's one person. I would say planetary science is all about probably community. Instead of looking at one person, but one person who has had a large impact on me is Dr. Carl Sagan. I would say, you know, where because he published a bunch of books, and I have read other scientific books, but he directly talks about the role of skepticism in science. I don't think many people have captured that, that thing that well. And if people want to watch, there's a show called Cosmos, 90s, 70s. Neil deGrasse Tyson is also carrying on, like that, carrying forward that legacy of Cosmos. And these brings us stories of different sorts of eras, maybe in astronomy, maybe in something else, and how that has shaped the evolution of Earth and also how we see space. So I think Carl Sagan is. I think he is a very big name over here. I in fact after coming to Michigan, I have met so many senior scientists. Everybody has a Carl Sagan story, and he is like a connecting dot. Like also because
Yeah.
not just a scientist, he communicated the science to the public.
Right. Which is so important in these days. Speaking of climate science as well. All right. With that, Ananyo, thank you for sharing your story. This has been one of the really good episodes of Indian Diaspora Podcast. The world of planetary sciences is fascinating. The journey, finding your ikigai, what you love, and opening doors in your journey. Thank you for sharing that through your story, and then
Right.
applying all of this knowledge, let's say, through climatic sciences that humanity needs now. Thank you so much, Ananya, for joining
Yeah.
us.
Thank you so much, Rahul, for inviting me. And I think every time I see some of your podcasts, they're from a very different field from the previous one, and I think it's really inspiring. What you have been doing, and it's connected to the fact that we also met somewhere else, and now we got connected again. And yeah,
Absolutely. It's the Indian diaspora. We are doing wonderful
yes,
things. All right. Thank you so much, Ananya. Take care.
yeah. Thank you so much.